Let's take a look how we can use VERICUT Drilling and Fastening to program fastener insertions. So the way that we go here is we go through Design Locations, Open, to bring in my locations, and here we have, I'll zoom in this dialog, we have a series of points displayed. Now these points are rather rich in data. If I look at them in this dialog here, we can see that we've got a high amount of information associated with them. For example, what material that is expected to be encountered, the thickness of the stack, and how many materials are in that sandwich. So if I just go to the fastener programming dialog, walk through the processes here. So the first one, we have taken the one point here, which is an inspection point for a positioning sensor. Then we've got fasteners 1 through 9. We've got the particular type of machine macro which will be used to insert it. Then we can order and sequence, so we can say make this one the first one, and the sequence is displayed in that way. We've got the transition points, so the transition points represent how the upper head or effector will move, so how it will move over the point into the location. So we can have a different clearance for each of these. We can also have certain waypoints. So a waypoint can be considered a coordinate system which is associated with a point to guide the machine over the assembly. Then we have the generate NC code icon, and I'm just going to give this program number and write the NC program so it's generated or post-processed. And here we can see the functioning lines. There are a bunch of comments here which is just help, but as they're comments they're ignored or can be stripped out at a later stage. And what I can do here is just go to Fastener Programming, hit Simulate, and the brand new program is dropped straight back into our simulation session here. So with this active, what I'm going to do is run the simulation again. The upper head or effector comes into position, structure is rotated, the lower anvil comes up into position. I can display that in this window here, and I'll have my bottom left window just to show the uppermost anvil. Zoom into here and we can see the fastener being inserted. Now the interesting thing about this is that this is updating the potential collision risk. So one thing that we have to be sure about in fastener programming and simulation is that we're looking for collisions with both the fasteners and also the structure. Maybe you can see here that the lower anvil is colliding with the structure. Now this structure, well, we've got a flying height here of 50 millimeters. Now if we just measure how big this is, 127, so clearly the distance needs to be adjusted, so I'll do that straight away. Both go straight into program, fastener programming, and I'm going to adjust that flying height to 150 millimeters. Write the NC program again, place into the VERICUT simulation tree, so we just hit reset, simulate, and we can see again the machine positioning the fastener, lower anvil coming into position, and we've now got a lower flying height measured in V of 150 millimeters, so we should be good to go. So let's just run this, make sure there are no collisions. Yep, save, retract, no errors, no warnings, program looks good to go. So that's a quick look at VERICUT Drilling and Fastening.